What is steel? A very simple steel is an alloy made up of iron with a small amount of carbon. Why would we want to add carbon to iron to make steel? What advantage is there in doing this? Well, let's take a look at some properties of pure iron and hot-rolled 1020 steel. The number 1020 means that the steel contains 0.2% carbon. The two properties that we will take a look at are the yield strength and the thermal conductivity. The yield strength of a material is the amount of stress that you can apply before the material will permanently deform. It's a measure of how strong the material is. The thermal conductivity is a material's ability to conduct heat. The higher the thermal conductivity, the better the material is at conducting heat. The yield strength of pure iron is 50 megapascals, and the yield strength of 1020 steel, which is mainly just pure iron and carbon, is 200 megapascals. That's quite an increase in strength. How is it possible by only adding 0.2% carbon? That's such a small amount. Well, this is possible because the carbon atoms make it hard for the steel to plastically deform, and therefore it makes it stronger. To get technical for a moment, it prevents dislocation motion. A dislocation is a type of imperfection in a material's crystal lattice. It's an extra half plane of atoms. And this is what allows plastic deformation to occur. The carbon atoms prevent this motion and thus plastic deformation. The thermal conductivity of pure iron is 80 watts per meter K. And the thermal conductivity of 1020 steel is 52 watts per meter K. The thermal conductivity of 1020 steel is less than pure iron. Why is this? Well, heat is transferred through two mechanisms, the motion of electrons and the vibration of the crystal lattice. The carbon atoms get in the way of the electron's path, kind of like speed bumps, making it more difficult for the material to transfer heat. This is the case for most alloyed metals. The pure form of the metal is more electrically and thermally conductive, but less strong. So are there different types of steel? Yes. There's carbon steel, tool steel, stainless steel, alloyed steel. So let's talk about each. Carbon steels are divided into three main classes. Low carbon steels contain less than 0.3% carbon. Medium carbon steels contain between 0.3 and 0.6% carbon. And high carbon steel contains more than 0.6% carbon, but not more than 2%, at which point steel becomes cast iron. Even though this class of steels is called carbon steel, there are usually a small percentage of other alloying elements. So carbon steels are strong and often used for things like structural components, gears, bolts, nuts. Tool steels contain alloys such as tungsten, chromium, vanadium, and molybdenum. They're hard and heat and wear resistant. They're used for cutting tools, dies, and knives. Stainless steels contain around 10 to 20% chromium. The chromium protects the steel from corroding by acting as a sacrificial anode. That means that it will corrode before the steel and provide a protective layer. Stainless steels are used for surgical equipment, silverware, and kitchen appliances. The alloy steel category is kind of a catch-all. These are steels that are alloyed with more than one element to increase things like strength, hardness, machinability, and toughness, depending on the end-use design requirements. Tool steels and stainless steels are also alloyed steels, but this category is much more varied in properties and uses. When the alloying elements, not including the carbon and iron, make up more than 8% of the composition, they are considered a high alloy steel. If it is less than this, then they are considered a low alloy steel. What are some of the alloying elements for steel? There are many elements that can be alloyed with steel. Here are a few and why they are used. Carbon is, of course, what makes steel steel. It gives steel its improved strength over iron, but it also gives steel the ability to be hardened through heat treatment processes. Manganese improves the steel's strength. Adding chromium to steel prevents corrosion, but it also increases its hardness. Vanadium is used to increase a steel's heat resistance and increase its hardness. This element is often used in the creation of tool steels. Nickel is used for corrosion resistance and to increase strength. Tungsten is another element that is used in tool steels to increase wear resistance and increase the steel's melting point. Along with these elements, there are so many more that are used to achieve a variety of effects. Molybdenum, vanadium, titanium, sulfur, aluminum, copper, lead, and phosphorus. There are so many things about steel that are fascinating. I hope you go and research yourself.